So we've been talking about the ESXi host, virtual networking, etc., virtual hardware, physical hardware requirements, etc. Now we're going to talk about virtual machine consoles, which is to say how you interact with a guest OS once you've built it, or at least once you've built the VM and at least need to start installing the guest OS. Um, you're going to need another computer in order to interact with that guest OS. There's no way, as I've mentioned concerning the DCUI, there's no way to interact with these VMs on the ESXi host directly. You can only do this using a vSphere client, the vCenter server, or the ESXi host. So you can use your vSphere client, tie into the ESXi host, connect to the desktop. Use the ESXi web client, use the vCenter server, things like that. You can also essentially, once the guest OS is up and running, you can either use VMware View or you can connect to it via a remote desktop if it's an operating system that supports remote desktop. Other things, of course, because it's at that point it's effectively a fully functioning a running guest OS. If it supports Google Remote Desktop, if it supports VNC, if it supports any of your other remote desktop solutions like AnyDesk, all of those will work, just as long as you have network connectivity to it. So in terms of, we're going to talk next about creating virtual machines. You can use the new virtual machine wizard from your vSphere client to create and manage those VMs. You're going to either select typical or custom. There's a lot of commonalities here between how we do these things with, say, VMware Workstation and ESXi host. You're going to have to make a choice about how you're going to build that virtual disk file, whatever its size. Thick provisioned, lazy zeroed, thin provisioned, eager zeroed, sorry, thick provisioned, lazy zeroed, thick provisioned, eager zeroed, and thin provisioned. Thin provisioned, of course, let me move this because I didn't realize. Thin provisioned, you will only have as much space as it actually needs. Thick provisioned, eager zeroed is going to allocate all that space, and all the remaining space is zeroed out when it's created. So eager zeroing, thick provisioned, that VHD, that virtual disk is going to take a little longer to build, but it will not take longer to use. On the other hand, with the lazy zero, it'll allocate all the space during the creation, but it will not initialize all those storage sectors until it actually needs them. So your trade-off there is work a little harder now and be ready later, or be ready now and work a little harder later. These are your choices. So, as I said, so thin provisioning, this allows your VMs to use the storage space they need, and not necessarily the storage space you tell them they're going to have. It reduces our costs. It can help with storage array duplication. You can configure alarms and reports to make sure that you're not at risk of over allocating your capacity. This also allows a little bit of over allocation, overcommitment, but not over overcommitment, but overcommitment, but not over delivery, shall we say? Over allocation is the idea of assigning more disk space in your virtual disks than is actually in your VMFS data store. And that is a valid approach, as long as you make sure that you suddenly don't need all of it. And if you realize as you're looking at auditing your storage use, you realize, oh wait, I am on track to actually need all the space I told these VMs they have. Well, then you can add more physical drives, add more storage to your data store, and keep going. And they'll never know the difference. Now, if you use the custom option, that'll allow you to do more things like change your virtual machine version, which is one of the things you'll see in the labs. You choose your virtual machine version, and these give you more options. And again, it's going to tell you, hey, with your virtual machine versions, you may not have all the things you want, all the features you want if you build this in the vSphere client as opposed to the web server. This also gives you options like not having a disk, or using an existing disk, or creating a new disk, or creating a raw device mapping connection. This also allows you to set up independent modes. Now, with independent modes, there are two options: persistent and non-persistent. An independent disk mode if a persistent disk will maintain its changes immediately and persistently. With a non-persistent disk, whenever the VM is powered off or reverted to a snapshot, everything that has changed about that VM goes away. It's like having a program like Deep Freeze on a lab computer or a library computer. Every time the system reboots, it goes back to the way it was at the moment it was frozen. So browsing data goes away. Whatever files the user has created on the system since the last reboot will go away as well. That may be a good thing or a bad thing, depending on what you're trying to accomplish. Now, raw device mapping is a file stored in a VMFS volume that is basically a proxy for a physical storage device. Basically, it's like in Hyper-V when you're setting up your virtual hard drive. If you're setting up your virtual hard drive and say, oh, by the way, use this physical drive, this is essentially what we're doing. The guest OS is going to store data directly on local or SAN storage, basically writing through to a physical partition. It may provide faster data access. It's good if you're running. Now, if your applications have to know the physical characteristics of the storage device, say they have to know make, model, speed, etc. For whatever reason, you may actually need RDM rather than a virtual hard drive. Or if your VM has to work with actual data on a local disk. The thing about virtualized storage is your virtual hard drive is a file. And depending on the way things work, that virtual hard drive file could be split up on multiple physical drives, say striped onto a RAID array or whatnot. So depending on what you need, you may have to de-virtualize that storage, shall we say. Now, so talking about provisioning types, as we mentioned, thin provision is your fastest. It allocates and initializes on demand. The layout varies. File blocks are zeroed as the blocks are allocated. On the other hand, thick, eager zero, slowest, fully pre-allocated. There is the better chance of contiguous file blocks, which is to say, there's a better chance that your storage will not be fragmented if you go for a thick provision eager zero configuration. And even thick provisioning with lazy zero, you still have a higher chance of fragmentation, as opposed to of non-fragmentation, shall we say, as opposed to your thin provisioning, where you might have to drop the sectors wherever you can onto the physical drive. And I explained that. Let's see. So yeah, there's that. I've covered all of this. Good, good. Okay, so we've got your options here. This is basically a graphical view of what we've just discussed. So your thin provisioned is 80 gigs, but only 40 in use. Your thin provisioned would be, actually, so this is also thin provisioned. A thin provision is 40 gigs, but only 20 in use. Your thick provision is 20 gigs, all in use, and it ends up in, it goes, all of it comes out of this 100 gig data store. This is one of the reasons, if you're doing, particularly if you're doing this for this course or others on your own hardware, it really might help to have a large external hard drive, because if you're creating multiple data stores for your virtualized ESXi hosts, and you need 100 gigs here and 100 gigs there, that adds up. So let's look at the GUI. This is kind of what the GUI looks like. It has a lot of the same. This is what the vSphere client GUI creation process looks like, the end of it. Choosing your virtual device nodes, giving it a SCSI bus and host number on that bus. It's a lot of the same flow that we experience with VMware Workstation, but just a little bit different in terms of look and feel. You'll make a lot of the same choices in more or less the same order, but it will be presented to you just a little bit differently. Now, creating virtual machines. So, we have a couple of options here. An RDM is going to go through, is going to have a VMDK that remaps to a raw storage location on an NTFS or ext3 physical drive. Whereas with your virtual disk, it's a VMDK that's either in VMFS or NFS. So thank you for watching. We've got one more video. We're going to summarize the chapter and then be done. I haven't made the demo videos for most of the demo videos for chapter 7 yet, but those are forthcoming. Thanks, and we'll be right back.